Happy, Peter? All right. First things, I've got
a question here, if I may.
Yeah, go ahead.
Well, I got a few questions. Just sort of starting from the end, he said black holes, if they exist, it's one of those things that has never been absolutely firmly proved, but the theory still persists. And this applies to quite a lot of things, like that Planet 9, for example. There's no absolutely solid evidence, but the theory still exists. It persists, should I say. If these things can't be proved, why do they persist? I mean, why don't these theories just die a natural death?
Okay, first of all, not quite true. There's no evidence for a black hole or Planet 9. Planet 9 can be inferred from the orbits of various things, which can the best explanation from a physics point of view is that there is something in a certain position of a certain mass affecting their orbits. So that's where it comes from. It's not based on nothing. It is inferred from observations of the pattern of the orbits of the planets and so on. So that, whether it's something of a certain mass in relatively a certain position, whether it's dense enough to be a small black hole or maybe a neutron star, small neutron star, or just a large planet which is just dark and just far enough away to be difficult to see. So that's that. And then black holes, I mean, you've seen that they have been imaged. The mass and density of the object viewed, I think they said M87 and even Cygnus X1, they were able to image nearby stars and so on, which from the orbit they could infer the density and mass of the object, and the density makes it smaller than a neutron star. So something which can't be seen, which is smaller than a neutron star, it's pretty much sort of almost conclusive proof of the existence of a black hole. Just what I would question is whether it is a singularity or something not quite a singularity. I don't think that can be proved, but I think it is something which is small enough to have enough gravitational pull to prevent light from re-emitting from it. So that's, by any definition, actually a black hole. So, that has been measured, has been observed and inferred from the viewing the orbits and the excited gas around it, right? The radio image that was taken, that very large telescope over the whole Earth. So that's definite. I just want to share, Peter, do you agree with my comments or disagree?
Very, I can't make a judgment on that. I mean, I think your comments are very are fair enough. I think what you're basically saying, just to put it in a nutshell, is that it's the best explanation we have. It's not perfect, but it's the best we have.
The science shows that it is something which is too massive and too dense to be a neutron star. What else can it be?
Yeah.
That is shown by the calculations, observations, and science. The same thing with Planet 9. There is something out there disturbing the orbits of the planets and so on, which has to be in a certain orbit, in a certain position, and have a certain mass. you know, just how dense that mass is not absolutely determined by those observations, but there is something there. And I mean, this is something that Amanda has actually been working on. There is a sort of a cut of a large gap in that. Not sure what it is. Not the Oort cloud, but I don't know, the outer sort of mini planets and so on. I remember Amanda speaking about that. There is, if something has swept away and cleared out beyond a certain radius, and that also indicates that there is something there of massive gravity which has sort of collected everything in its path on a certain orbit. So, you know, speak to Amanda about it. She's been looking for this thing, I think, for years. So, yeah. Then I just want to share something else I've got here. Here's my share thing, share screen. So I think that Peter actually had this in the newsletter as well, but this was just imaged by simultaneously, it seems, by Chandra and James Webb, where they found this black hole dating back to 470 million years after the Big Bang. Even further than the ones that were mentioned in the video. What's amazing about this, look at the figure here for the weights. It's believed to weigh anywhere from 10% to 100% the mass of all the stars in its galaxy. Whereas the multi-million solar mass black hole at the center of our Milky Way is an estimated 1% of the mass, or 0.1% of the mass of our galaxy. So, I mean, this thing, relatively speaking, is enormous. And it is very old. So this rather, the theory doesn't cater for the existence of these things. So the theory needs tuning, at least, maybe totally change. So this is exciting stuff, actually. We're going to find, I think, even more controversial things. We can only find more. And with all the newer fancy telescopes going up in the next decade or two, come up with results, it's going to be fascinating. All right. Anybody else? Peter? I don't know. You happy
yes,
or not? You didn't sound happy.
Yeah, I have two comments. What if Planet 9 were naturally a black planet and you're looking for a piece of coal in the black sky? And the other one was, is a neutron star, is it made up of neutrons, or that it's got no positive or negative charge? And what would be smaller than a neutron star?
Well, smaller than a neutron star, look, I think Pierre, just help me here. I think you get white dwarfs, and then smaller than that would be a neutron star, and smaller than a neutron star, well, quite frankly, I would ask the question, is it possible to get a quark star? And could a quark star be a black hole? I mean, if you get something, a quark is much smaller than a neutron. So if you could collapse quarks to be, grouped together in close proximity with each other, then that, you've lost 1,000 times the diameter of a neutron in the sort of empty space around quarks. If you could be right next to each other, they'd be 1,000 times smaller than the neutron star. I think it's small enough to actually act as a black hole. Personally, I don't know why nobody talks about anything like that. Why does it have to go from a neutron star to a singularity? Why? You don't have to have a singularity to have a black hole, as far as I'm concerned.
Yeah, but I was also wondering whether you can see one. If it's a neutron star, it would have no electrical charge, and how would that affect things like X-rays and gamma rays and light when there's no charge, no perceptible charge.
Um,
We used to
I think there's
electron.
no electrostatic charge, but what you do have is a very strong magnetic field in some of them. Pierre, just help us here. Can you hear us?
Yes, I can.
You get neutron stars with a very strong magnetic field. Is that right
Yes.
or not?
Yes. Pulsars are neutron stars with very strong magnetic fields.
So that's how we can see them. They interact.
Yeah,
the magnetic
rotate
field
very
causes.
But I just want to comment, Planet 9 cannot be a neutron star. A neutron star forms from the collapse of a massive star. In other words, 8 to 10 solar masses, not 6 Earth masses of Planet 9. So
It'd be too heavy.
That's not possible, mass-wise.
Okay.
Theoretically, it could be a small black hole, a wandering black hole. You do get, but that doesn't tie in with the projected orbit they showed that he showed in one of those. I don't know. So it is a possibility. But just about the existence or the reality of black holes, Pierre Hugo always did not believe in the existence of black holes. And I think he eventually conceded when there were orbits published for 13 or 14 stars that orbit around our galactic supermassive black hole, short periods for 13, 14 years. And then he eventually said, yeah, well, that is gravitational proof of, what's it, 4 million solar masses of Sagittarius A star. But just a totally different comment. I think the whole concept of primordial black holes is probably going to be revived by this kind of article, because primordial black holes form from the collapse of energy, not mass. In other words, not after, not stellar collapse. And that this observation could fit in with Stephen Hawking's idea of primordial black holes. In any case, it's interesting times.
But
interesting video to look at.
yeah, but the planet, as far as the theory that Planet 9 might be a primordial, I mean, how many masses is the estimate of that object? 6 Earth
masses.
I mean, a black hole of 6 Earth masses. What would the diameter be? I mean, the mathematics of a black hole that size shows that if there's Hawking radiation, it shouldn't last very long, would it?
Yeah, that's true. But I mean, 6 Earth masses is minuscule for a black hole.
Yeah. So if it was a small black hole, it wouldn't. I mean, it might be long gone. It might have been there in the past, then, but then it wouldn't be there anymore. It would have evaporated. So yeah. And this whole thing, I don't know. Interesting, the concept of energy collapsing to form a black hole. How does that happen? Is there any sort of theory as to the mechanics of that?
Just Google.
Does the energy convert to mass in a concentrated form? It must somehow.
Well, if the wiki story says you need fluctuations in energy and very high concentrations thereof, and then that can collapse into a primordial black hole. In other words, it's got nothing. It's even primordial. The term primordial, I think, is correctly described as before there were the first stars formed. So those black holes did not depend on stars forming and collapsing to form black holes. They formed before there were stars. And this observation that you're just publishing now might point in that direction. Because I mean, James Webb definitely found very old black holes and very large black holes, which surprised everyone.
So they had to form very big, very quickly. I mean,
Yeah.
this thing is 10 to 100% the mass of all the stars in its galaxy. That's 1,000. If it's 100% the mass, that's 1,000 times relative the size to our 4 million solar mass supergiant black hole. It's just mind-boggling, utterly mind-boggling. And then, okay, anybody else?
A technical question that's been bothering me is there a vacuum in space? Because every time I hover, you wonder how would a rocket fill the space to give it any forward propulsion? Against what does the rocket work?
The rocket doesn't push. It doesn't have to push against anything. It is the mass of the propellant itself, which is rapidly expanding backwards out of the back of the rocket, causing the opposite reaction for the rocket to move in the opposite direction. So the two are pushing against each other. It's not pushing against anything else.
Newton 3.
So it's the propellant has got its own fuel and its own oxygen, or whatever is chemically combining. There are, of course, other methods of propellant like that ion engine, which is just shooting off electrons or shooting off, plasma in one direction and pushing the vehicle in the other opposite direction. So there's not actually a chemical reaction there. That's simply a plasma being charged to a very high charge and then shooting out the back.
Isn't it a bit like using an aerosol can to spray down a vacuum cleaner?
Yeah, it's just the mass of the propellant multiplied by its velocity has a momentum. So momentum is mass times velocity. So if you have something with a propellant, if it's a gas or liquid, not very dense, but it's ejecting at such a high velocity because of the energy of the reaction, that the momentum is enough to propel the heavy rocket forward. It's a simple calculation.
Right.
It's a simple engineering calculation.
Newton says
It's not a car with tires pushing on the road. It's literally,
exactly.
You can have a car with no drive to its tires, but with a jet engine. That jet engine is not drive. If that was in a vacuum, it would still go forward at the same speed, or probably faster, because there's no resistance from air.
It works better in vacuum than it does in atmosphere. But it's Newton. For every action, there's an equal and opposite reaction.
Yeah, simple Newtonian mechanics.
It couldn't be a jet engine. It would have to be a rocket.
Yeah, no, a jet engine ingests oxygen from the atmosphere. So
there it's got the pressure of the
engine
atmosphere.
is the only difference. The difference between a rocket engine and a jet engine is that a rocket engine has its own oxygen, its own oxidizer.
It's not accurate.
Sorry, what's not accurate?
No, I say it's not accurate because a jet engine is merely taking the available mass of air. It doesn't matter if it's sort of helium or oxygen or neon or whatever. It's merely taking that and adding energy to it by atomizing some sort of fuel, and therefore increasing its velocity in a certain direction. That's how the jet engine works. So it needs a medium around it. It can't work in a vacuum, whereas a rocket is merely providing all of the oomph and sending it in one direction, which sends the ship in the other direction.
A jet engine, sorry, beg to differ. Jet engine actually is more efficient at high altitudes, where you have less air.
Yes, it does, but that's a lot to do. Yeah, that's a lot to do.
The jet engine is again, it's a chemical reaction.
Resistance.
It uses a fan. It uses a fan to suck in the air, which compresses and heats it up, and that ignites a fuel and oxidizes
But
the
it-
fuel, which causes an
you do
enormous ejection
you
out the
get
back.
to
The net
you
effect has
get
got
to
nothing to do with how much
eventually-
air you're sucking in. In fact, if
you
you've got
eventually
less
get
air
to
to
an
suck in, it
altitude-
goes faster.
Yeah, you eventually get to an altitude where there is just not enough matter.
No, it's
To
not. It's not enough
activity.
oxygen. Is the operative word.
No, it's nothing. No, it's
Yeah.
Derek. It's nothing to
It
do
is
with
the oxygen, Peter. Have a look
Oxygen
it
is
up.
merely a medium for the ignition.
It's a
That's all it is.
chemical reaction. It's a chemical reaction of the oxygen combining, oxidizing the fuel. That creates the heat and expands the fuel rapidly out the back.
Yeah, that will work where there is
Again, it's the mass
density.
times velocity equaling the momentum of the fuel out the back, pushing against the mass of the jet.
Yeah, but it's still working through a medium which is dense enough to push against. But
No,
in
no,
space,
sorry,
if
sorry.
there's-
The density of the medium has no beneficial effect. In fact, the less dense it is, the easier it is for it to move forward.
as long as there is some
The
density.
only benefit of that medium is the oxygen in it, which supplies the chemical energy.
Also, not quite accurate, Derek. There's a bit more to it than that.
But probably a bit more, but I think that's the main thing. I mean, there is an element of, you do have a fan, which is sucking the air through. But the net, you've got to look at the net effect of that passage through the engine. There is some resistance of the air going through the engine. Okay. So the net energy
Yeah.
is less. It's actually easier for the jet to move through thinner air, as Pierre was saying.
Yeah, well, as long as there is some density, enough to keep it going. But
No,
in space,
No. Sorry, that's the
there's
wrong
no-
concept. You must drop that concept. It's the wrong concept.
but now in space there is no density.
Exactly. You don't need any density. You just need Newton's reaction, equal and opposite
You
reaction.
just need momentum,
Yeah.
momentum and gravity.
Yes. Momentum in two opposite directions.
Hi, Derek. If I may just chip in here, getting back to the topic of the detection of black holes, did I hear correctly that that extraterrestrial LIGO system, those 3 satellites that would link up, would be operational by 2025? Was that correct?
I doubt it. I think that might have been the original target. You probably got to add a few years to that, or a couple of decades maybe.
I think a couple of
Laser interferometry something array.
gravitational wave observatory.
Yeah. Yeah, that's for
2020 expected to be 2027 that get that thing running. But the other thing, I was just going back to your bit about jet engines. There's one thing you should take into account is the Sabre engine that
Yeah.
takes off with air and winds up as a rocket. But all of them rely on the one thing: it's basic Newton's behavior. You chuck something out in one direction, equal and opposite in another direction. And in all
Yeah,
cases,
so
you either
the ramjet effect of the Sabre, the only thing that is doing is it no longer has a fan sucking the air in, because it's going so fast it doesn't need it.
no, it
It's
does.
just,
It
it's
compresses
just
the
getting enough
front end.
air in the front to keep it going. That's all it is.
With the Sabre engine, there is a fan in there, and the whole front end has changed to the effect that they have such compression that the air or the medium that's coming in is liquefied, or damn nearly liquefied. That's the whole principle of it. A turbo ram rocket, it was the original speaking to that. I did a lot of reading up on that. I thought it was most interesting. So, having served in the Air Force and buggered about with jet engines anyway in Canberra's, that tells you how old it was. And I was very interested. Sabre engine was a British development.
Okay, I'll look it up. Sounds interesting.
Yeah,
But there,
it is.
one thing I know, the diameter, for example, of a Boeing engine, why they go to bigger and bigger diameters of engine, they have those huge things. It's the increase in efficiency, because you're working with half mv squared, the acceleration,
Yes,
half
quite
mv
right.
squared. So the velocity. So if you want to increase thrust by speeding up your air going through, you actually lose. It costs you the square of the velocity in additional energy. So if you increase the velocity throughput by 10%, you increase the energy requirement by 21%. The square of 110%. So yeah, which is obviously 121%. So you increase energy requirement. So they make much bigger diameters. So you're just increasing the mass going out the back by increasing the diameter. So instead of increasing the velocity, you're increasing the mass. So it makes it much more efficient. That's just one thing to note there with jet engines.
Oh yeah, you're still heating up a material, and it can't it expands, and it can only go out the back as a jet, and its velocity increases. So here your mv squared works, and that's, no matter whether you use air, oxygen, nitrogen, or the hypercolloids, which
Yeah. Well, whether you've got a
explode.
lower mass at a faster velocity going out the back, or a higher mass, slightly lower
That's
velocity,
correct.
the total sum is the momentum. It's the momentum going out the back of the air fuel mixture injected out the back, which gives the opposite momentum to the jet. So yeah, it's a simple calculation.
Yeah, go along with that. Go along with it.
All right, so
the
black holes, I think we've got interesting times up ahead. Yeah. By the way, I don't know if it's worth mentioning, but I've been looking at a couple of articles where people are now saying, where this whole thing where you have to quantize gravity. I think they're looking at that might not be necessary, and maybe you can have alternative theories. Gravity doesn't need to be quantized for gravity and quantum theory to be united. So I don't quite understand what the people are talking about all the time, but there are a couple of articles. If anybody's interested, I can send you a couple of that. Maybe we can briefly talk about that another time.
I mustn't say that in the presence of Ravelli.
Yeah, so Carlo Ravelli, I think him and a couple of other people had a bet with I don't know who, with the people saying that you don't need to quantize gravity. Was he going against it or for it? I can't remember.
Carlo Ravelli is for it.
He's for quantization of gravity.
Yeah, I would imagine so, because
I'm inclined to the non-quantization of gravity makes more sense to me. I believe that gravity is an emergent phenomenon, and quantization is effectively each subatomic component has its own sort of frequency and so on, wavelengths, and are quantized at different frequencies and different values and so on for each component. And if you've got all these different quantizations of different components all in one complex compound molecule object, whatever, I think they all sort of neutralize each other, and I believe that's why, to me, that's my concept. That's why you don't see quantization on the scales that we live in.
Yeah.
And I believe the same thing applies to gravity. I believe there is an interactive effect between all the other fields going on and gravity, which has a sort of averaging effect, which sort of negates the quantization. There is quantization in it, but because it's so complex, it effectively is not there. There's a sort of smoothing effect. That's my point of view anyway. I'm sticking to it.
doesn't
Ah.
quite agree with Einstein.
Well, thanks very
No.
much. Quite lively.
Pierre, what was that comment about Einstein?
Your view does not agree with Einstein's.
Okay, Einstein didn't agree with
John
himself. What time?
Archibald Wheeler, that mass determines how much space must curve, and space determines how mass must move.
Okay,
So-
I would word it
We're
slightly
talking-
differently. You come up with the same effect, but it also explains my view.
Okay.
If you
listen,
you
I'm
say
going-
mass determines, but I would rather say mass is linked. Mass is linked to the way space is warped, and space warp is linked to the way that mass behaves. I prefer that. In other words, that's in an emergent effect, not in a
Semantics.
deterministic effect, but an emergent effect
Mm.
from some other link, some other process which we've yet to discover.
Derek, I must take my dog for a walk. So
Okay.
thanks. Interesting.
That's a good one.
I think we're getting to way out in our stuff here now. So thanks everybody for
Bye,
your
everyone.
time. I think everybody's probably quite hungry by now. So let's go and have some.
Very lively.
Thanks for attending.
Thanks,
Very
Derek.
Right
lively.
on.
Thank you.
Yeah, good
Bye.
night.
No.
Cheers, everybody.
Let's go.
Bye,
let's
everybody.
go.
Thank you.
Oh.